All right. Welcome. This is lecture 8. We've finally gotten to the point in this class where we can talk about supply and demand together, and we will finally see some things that look like what we saw in Principles of Micro, wherever we took that. Um, and the easiest case to consider is the perfectly competitive market. All right. This is always the base case for any economic model. It has the most simplifying assumptions. And so this is I mean, think about what that means, right? Simplifying assumptions. It makes the modeling part of things easier. All right. This is usually just to get like the intuition of a model first. And then you would want to like an economic researcher is going to first consider the perfectly competitive market, and then we'll consider deviations from perfect competition. This is usually just a benchmark case. Um, yeah, and in perfectly competitive markets, this is usually where we see um, max efficiency. This is usually where we see like this is the best case for the consumers. Any type of market power is going to take us away from perfect competition. And this is often good for, more often than not, this is good for the firms. This is bad for the consumers. All right. So perfectly competitive markets, this is often the best case for the consumers. All right. But we know in real life, our market's perfectly competitive. Some are, many are not. But for modeling purposes, this is where we want to start. All right. And then I guess as a little preface, as a little preface, I just want to give this little categorization of types of markets. You can kind of broadly categorize markets into four broad categories. You'll have perfect competition. You'll have perfect competition. You'll have what is known as monopolistic competition. Then you'll have what's known as oligopoly. And then, of course, we have the monopoly. All right. Those are the four broad market categories. Of course, today and for like the midterm that's coming up, we're only going to consider perfect competition. But these are generally how you can categorize markets. In reality, um, let me write here. We have when we consider the number of firms, this is often this is often increasing in the left direction. What I mean by that is that perfect competition, this is where we have the most number of firms. All right, perfect competition, we have the most number of firms. Monopolistic, we have a bit less firms, um, but there's still a lot. We'll still face a downward sloping demand curve because of this. Um, and then we'll have oligopoly, where it's just a few firms in the market, just a few people can supply the market. And the monopoly is the most extreme, where there's only one supplier for the market, and they can charge the highest price and produce the lowest quantity. Prices, some characteristics of these different markets. Prices, often lowest in perfect competition and highest in monopolies. So as you might be picking up, uh, the perfect competition and the monopolies are two extreme cases. In reality, most firms, most markets in the world exist somewhere in the two in the middle, but we like to consider either one extreme or the other for the sake of illustration, you might say. Another thing is that the quantity, the number of things that gets produced, we know that has an inverse relationship with price, right? So it should make sense that we see the highest quantity of output in perfect competition. We see the lowest quantity of output in monopolies. And then somewhere in between, we always see a mix. Now, the last thing I want to say, because those other market structures are not too important pre-midterm, but we're going to talk about them a little bit after the midterm. Um, this is usually this is just one of the key features, and we're going to go into some key features of perfect competition. But one of the key features is identical products. That usually denotes a perfectly competitive market. Whereas monopolistic competition, they have what is referred to as differentiated products. And then oligopolies and monopolies, you'll usually have a unique product. And monopolies, you also have a unique product. And in perfect competition, you'll have identical products, so everybody's selling the same thing, and you'll have many producers. In monopolistic competition, you'll have differentiated products. Everybody's selling a little bit different thing, but you will still have many producers. Whereas in an oligopoly and a monopoly, you usually have, for the most part, it's like one product. Generally, it's like one type of product. Um, Whereas in oligopoly, you will have just a few producers. And then finally, monopoly is the most extreme case. There's only one producer, one supplier. So when an economist is looking at a market and they're trying to make some like economic insights about this market, they're trying to give their expertise about a market. One of the most important things, the first question that they need to address is what kind of market are we dealing with? And like I said, for the most part, just like many things in life, right? The answer is often not black and white. It's not the extremes, but the answer often lies somewhere in the middle. So many real life markets exist somewhere in the middle. But there are instances, there are examples of the extremes, right? The extremes. I won't have to go into this too much here, but usually we think of like food businesses as perfectly competitive, especially like fast food businesses particularly. But then there could be an argument to be made that maybe that's more appropriately modeled as monopolistic competition. And then on the other extreme, we have monopolies. So you'll have like for the longest while, Google had a monopoly on the search engine business. And then maybe a more relevant, relevant example is like in the market for marketplaces. Like think of all of the online marketplaces that you can buy from, not selling any one particular good, but like where is the first place you think of if you're gonna go these days, if you're gonna go online and buy something? Probably going to see if it's available on Amazon. All right. So Amazon has a monopoly on the market, the online market, like the market for online markets. All right. And then an argument could be made that maybe that's an oligopoly because, like, what about Walmart? Walmart is one of the few firms that can compete with Amazon on similar scale because they've been around for so long. They have so many connections with suppliers. They have these logistics, like distribution systems. They have these supply chain deals that Walmart is able to compete with Amazon, but there are not many firms that can compete with Amazon. And that distribution thing has quite a lot to do with it. But this is just some background. This is how this stuff gets applied in the real world. For the purpose of this class, or at least the pre-midterm stuff, all we need to look at, or all we're going to look at, is going to be the perfectly competitive markets, because this is the easiest thing to work with mathematically. All right. So without further ado, let's begin. All right. So we're finally ready to tackle supply and demand together in equilibrium. All right. And the first thing we want to consider is a perfectly competitive market. All right. So for our modeling purposes, we got the intuition just before, just above. But for modeling purposes, how do we define a competitive market? Well, as I said before, there are many firms, but as a result of consequence, a more important consequence of this is that there are a ton of firms. Not a single one of them is large enough to influence price. All right. So this is what I've been referring to as a price taker. A firm in a perfectly competitive market must take whatever price that people are paying. They have no say in what they can charge. They must just supply what people are willing to pay. All right. Um, oh yeah, I have it right there. Still, still important. Um, yeah, no firm is large enough to influence price. And then also what I gave above is that in a perfectly competitive market, we generally in this type of market, there's more or less no difference between what I'm selling versus what the guy down the street is selling versus what you might be selling. If it's a perfectly competitive market, all of our products generally do the same thing, like the exact same thing, and there's not really any difference between them. To put a vocab word to it, we call this homogeneous products. And in this case, this implies that consumers, the customers, don't care who they buy from. They don't care if they're buying from me or you or Brody down the street. It doesn't matter because all of the goods, it's like you can think of this as like charging, maybe like charging cables or like AV cables, more of like the like an HDMI cable, right? For the large majority of folks, it doesn't matter where you buy your HDMI cable from. It's going to serve its same purpose. It's going to connect your computer or your console to the screen and produce an image. All right. So you don't care if you're buying from me or you or the guy down the street. As long as the thing works, I'm cool with it. And this kind of one of the intuitive reasons why the firm has no say in pricing power. It's all about the consumers have the pricing power here. A thing that is it's worth noting and it's worth knowing, but it doesn't appear too much right here, right now. Maybe after midterm it will appear, is that the agents have perfect information about prices. This is one of the cool things about econ. Like if you're actually liking this stuff, and I know a few of you guys said that you guys want to learn more about like uncertainty in decision making. One of the things we like to consider, and we're even able to consider with econ models, is how much information do people have about what they're buying or what they're selling or who they're hiring or so on and so forth, things like that. Um, the best case scenario is when there's nothing hidden, when there's no hidden information. All right. And that's what we call perfect information. And so when both sides have perfect information, this is when efficiency is the highest. This is when the best outcome happens for everybody. All right. They won't be too relevant here right now, but it's just important to note going forward. So in perfectly competitive markets, we assume that everybody has perfect information. All right. And then finally, something that will be relevant for this lecture is that there are no barriers to entry. This is more so a thing for the long run. But think about like starting a food business. There's really, I mean, it's going to be little or no barriers to entry. I should a little caveat, no significant. Like maybe I think for here in Seattle, I think to start a food truck, all you need is like a small license to just say that like that you've paid a cost and your food truck or whatever your business is as passed like health code standards. Um, and so often these costs are very small. So excuse me. All right. Sorry about that. I had to take a small break. So often those costs are very small. And so we don't really consider those as significant barriers to entry. And so it's very easy for firms to enter this market or for firms to leave this market. It's more relevant to entry. You don't really think about like barriers to exit, but you might think about like what is the cost of having to liquidate your inventory. There are a cost associated with bankruptcy, and so there are kind of barriers to exit that you might want to consider if you want to get more specific, more particular with your analysis. All right. And so what are the implications of these assumptions? Like I said, this means that firms are price takers. And then more importantly for our modeling purposes is that this means that the demand for these products is perfectly elastic and the demand curve itself is horizontal. All right. And so what I mean by that is that like if this is the firm specific supply and this is the market supply or the industry, then one of the things I alluded to is that the the customers have kind of all of the power here. The customers have the say on what is the price that things get sold for. All right. In perfectly competitive markets, there are the goods are not able, the customers are not able to tell the difference between goods. And so we generally assume that the customers kind of come to terms with like wherever the demand is for this product, this will cause price to sit at a certain level. And so you'll get a P star. Let me be sure I label my axes. That this is price on the vertical, this is quantity on the horizontal, and then same thing over here. So if this is the demand curve right here, I'm sorry, this is the P star, this is the price. Well, for the firm, this is the demand curve. All right. For the entire market, you might have a market demand curve, something like this. And then you'll have a market supply curve, something like this. All right. And the price that things get sold for, the market clearing price, that's the equilibrium price, will give us the Q star. All right. Meanwhile, the firm specific demand curve, remember I said that this is horizontal. So this whole thing for the firm is the demand curve. All right. And then I think I alluded to this in an earlier lecture, but what does it mean if a demand curve is horizontal? This means it's a perfectly elastic demand. And this is kind of like what you guys just saw in a homework question. If something is perfectly elastic, if something's very elastic, then as soon as somebody tries to raise the price and charge more, your customers are just going to go buy from somebody else because they don't care who they're buying from. All right. So what's special? What's another special thing about a horizontal demand curve? Do we recall, how do we define marginal revenue? Marginal revenue is the revenue that comes in from selling one additional unit. All right. So what's special about a horizontal demand curve? What is special is that marginal revenue in this case is constant. What does this mean? Or what do I mean by this? I mean that it's exactly that. That your marginal revenue, my revenue from selling one more unit, will always just be the price that I'm selling that unit for. All right. Because I can't charge more or less, I can't what is referred to as price discriminate. I must, since that demand curve is horizontal, I can only ever sell for that one singular price. Everybody's only buying for one price. If I try to raise it, they're gonna go buy from Buddy down the street. All right. So this is an implication of a horizontal demand curve for a firm. All right. Next, what just to get a little bit more intuition of what I mean by this, let's compare a perfectly competitive market to a non-competitive market. All right. For whatever reason, this market is not perfectly competitive. All right. So given the table on your screen and in your notes, take a few moments to fill in um, given these quantities and these prices. At this level, what is the firm's total revenue? What is its marginal revenue? And what is its average revenue? All right. And that means total revenue divided by quantity. And then do the same for the non-competitive market. And let's see what we find. All right, take a minute to do this. Shouldn't take you very long at all. And so what you should have found is something that looks like this. All right, this was a very easy exercise. I just wanted to do this to illustrate that in the perfectly competitive market, the marginal revenue, again, is its price and it's constant. So marginal revenue is constant in the perfectly competitive market. Whereas in the non-competitive market, we see one, this is going to be a downward sloping demand curve, right? If price is very high at its highest, then only one person is willing to buy at that price. But if price comes down a little bit, then now two people are willing to buy. It comes down some more than three, and then comes down some more than more people were willing to buy. As a result of this, the marginal revenue is not constant, but it's actually decreasing. All right. Because one of the flip side of a perfectly competitive market, it means that there's a lot of demand for things. It means that there's a lot of demand to go around. And so the marginal revenue is constant. That means, so like, even if there's a lot of things being sold, there's still like people are buying those things. Whereas in a non-competitive market, then as there are more and more things being sold, only so many people want these things. And that's kind of one of the reasons we see the downward sloping demand curve. Only so many people want these things. And so you can only charge such a price for these things. And that's why we have to get that inverse relationship between price and quantity. And so we see the diminishing marginal revenue, diminishing marginal returns. And we also see the same behavior. Everything I just said for marginal revenue holds true for average revenue as well. All right. Easy to see, but I just wanted to just do this with a toy example to just illustrate. So this was a key feature, right? This was a key feature is that in the perfectly competitive market, marginal revenue is equal to price, exactly equal. Why is this important? Well, it's going to have to do with, remember what a firm's goal is. A firm's goal is to maximize profit. All right. So how did we define profit? Profit is simply profit equals total revenue minus total cost. And then how do you maximize a function? Well, you maximize a function by setting its first derivative equal to zero. And if I have total revenue and total cost, then the derivative of those is going to be marginal revenue minus marginal cost. And I need this to equal zero. Of course, then if marginal revenue minus marginal cost equals zero, this implies that these two things should be equal. That is, the MR is equal to MC, the golden rule. All right. And then what does this mean? Remember, if MR is constant, then that means price is equal to marginal cost. All right. These are the reasons why we care about these little details. All right. So profit is maximized in a perfectly competitive market where price is equal to marginal cost. And marginal cost is often a function of quantity. All right. So just to summarize, MC equal to MR, which is equal to price, is optimal in perfect competition. All right. Small little details that make up a grander picture. All right. Very good. So, like I said, this is a very important feature of the perfectly competitive model. All right. The a critical feature is that the a firm produces whatever quantity such that its marginal cost of producing that quantity is exactly equal to the market price. All right. And because of this, this is where we're actually going to start to get the firm's supply curve. All right, the upward sloping supply curve. Um, Let me show you. Let me give an illustration. All right. So marginal cost is very much related to the firm's supply curve, but let me show you something. All right. So with the perfectly competitive market, we have a flat price line for P star. And then we remember from earlier that the marginal cost curve had this inverse, this U shape function, this U shape to it. So if we have something like this is your marginal cost as a function of quantity, because I have quantity here on the x-axis, then I have a price here on the y-axis. Well, we have this marginal cost curve, which has this U shape to it. All right. With, remember, the price is the amount that I'm getting. This is the money coming in, and my marginal cost is the money going out. So that difference is my profit. All right. So all of this area in between, this is your revenue minus your cost. All right. All of that difference in between is the profit. And so it's this area right here. All right. And so what am I getting at here? Remember, I said, or I asked this question right here on the notes, is that does this mean that the marginal cost curve is the supply curve? Not exactly, because what do we remember? One of the key things about supply curves is that supply is upward sloping. All right. So we have this minimum. You'll have a minimum somewhere. Just suppose that's exactly the minimum. And so the market supply curve is only the upward sloping part of the marginal cost curve. All right. Why is that? One of the intuitive reasons is why would I produce less when I could produce more? All right. And what do I mean by that? Remember, what is optimal? Optimal is where P star or is where our marginal cost is equal to P star. All right. Our marginal cost is equal to the market price. That means that there are two solutions here. All right. There are two solutions here that on the one hand, that means that I'm gonna move this over. Very good. That on the one hand, sorry, just suppose that's exact. All right. It's not too important. That on the one hand, you'll have Q1 right here. And on the other hand, you might have Q2 right here. There we go. All right. So the quantity that the firm's going to produce, why would they be okay with just selling a few things when they could do better by getting their name out there more? I think the camera is flipped. So they would not go to Q1. They would go to Q2 because this gives us more market share and this is better for the firm. In both cases, this is optimal. Additionally, if they were at Q1, if they were right here, then the firm could make some profit by producing more, right? Because that they have that the marginal cost comes down as they produce more up to a point, up to a point, and then it starts to go up. They wouldn't bother producing anywhere here. All right, they would not bother with it. What they would do is they would go and they would produce at Q2. And I'll make a note of that, that the firm chooses Q2 because this gains additional revenue or profit. They're not interchangeable, but they do gain more of each or market share. All right. So only the upward part of the marginal cost curve overlaps the firm's supply curve. All right. That's how we get a supply curve. So now we've seen how a demand curve is derived, and now we just saw how a supply curve is derived. All right. Supply curve is the upward sloping part of the firm's marginal cost curve. All right. And the demand curve comes from the consumer's problem, the demand for the product as a function of its price. Or if you take the inverse of that, it's the price of a product as a function of its quantity. All right. One and the same, they're interchangeable. You still get the downward sloping behavior with demand, and we get the upward sloping behavior with supply. All right. Next, let's consider, so we care, it seems like we care a lot about this marginal cost curve, and we do, and we do. All right. So, and then remember, let's consider this marginal cost curve, which here in the perfectly competitive market is equal to price. Remember, marginal cost here is where we want to be. Maybe I shouldn't say equal to price, but it's where we want to be, is where it's equal to price. So let's consider three cases. All right. We're going to consider what if the market price is above our average total cost? And then case two, what if it's below our total cost, but above our variable cost? And then case three is what if it's below our variable cost? These three cases will determine is the firm making a profit or loss? Profit or loss? It will determine that. And it will also determine do we stay in business? I should say, do we produce or shut down? Produce or shut down? These cases, depending on where the market price is, will determine the fate of this business. All right. And let's see what I mean by that. So when the price is above the marginal cost, remember we had something like so if this was our variable cost, and then we have something like identical for it for our total cost. And then we suppose that our marginal cost looks something like this. So we had AVC, ATC, and then we have a marginal cost. And we say, okay, suppose that the market price was right here. All right, right. Let me do this just a smidge better. All right. So suppose P star is right here. All right. So where is this firm going to produce? They're going to produce at the quantity at which price is equal to marginal cost. And we want the one that's more to the right. So they're going to produce here at Q star. And then what's this firm's profit going to be? Let's make notes of these things. Produces, the firm produces Q star, this many things. And then first, what is its, we should say profit equals total revenue minus total cost. So the total revenue, should have done this in black, and you will see why, but it's okay. Total revenue is equal to, how do we calculate revenue? It's just price times quantity, right? How many things are you selling times how much are you selling them for? It's price times quantity. All right. Mathematically, or actually I should say geometrically, what does that look like? Well, the total revenue is, we have this price and this quantity. So if I do P times Q, geometrically, graphically, I'm going to get this rectangle. All right. And then what about our total cost? All right. Usually I do cost in red, but I guess we'll do it in green. So what is our total cost? Well, we have our average total cost, and we remember that this is simply TC divided by Q. Then total cost is going to be average times that Q. All right, because if we times the Q, they will cancel. All right. In that case, what we will have is this is in the green. Usually I do red and blue, but no worries right now. So our total cost in this case is right here at this quantity. Our total cost is at this level. So all of that is the cost of doing business. Therefore, geometrically, the profit is that gap between the ATC and the price level, and however many quantity, whatever, however many units you're selling, because you're making this gap. Let's do it this way. This, this length, this distance, this gap on the y-axis should be that way. The y-axis is the profit per one unit. So if I'm selling Q units, then I'm not just making one, but I'm making that times Q. Thus, 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 profit is what I just wrote in the yellow highlight. All right. So when the price is above average total costs, this is the best case for the firm. All right, this is the good case. Why is this a smiley face? Because profit is greater than zero. All right. And that's the biggest thing. All right. Firm wants to maximize profit. Well, if they're able to make positive profit in a perfectly competitive market, the hardest market to be in, then this is great. All right. This is where the firm wants to be. And so case one, this is the best case scenario. All right. But what about this case? All right. So what if the price is below the average total cost, but still above the average variable cost? Well, what does this look like? So I'll have quantity again on the x-axis, price again on the y-axis. And then suppose I have something like, let's do something like this. Let's do something like um, average variable cost is looking like this. Average total cost, maybe there's a large fixed cost, there's a bigger gap. So this is ATC, this is AVC. And then our marginal cost, it's just something like this, we could say. Quite steep. And then suppose the market price is like right here. All right. So suppose the market price is here. All right. So then what does this look like? Well, off to the side, we know that profit is equal to total revenue minus total cost. All right. And so in this case, now I'm going to go back to blue and reds. All right. So in this case, where does the firm produce? All right. Where does the firm produce? The firm still produces wherever price is equal to marginal cost. All right. It doesn't matter what case we're in. That's always the optimal. You always want to produce where price is equal to marginal cost. And you don't choose that price, but rather you choose the quantity. So Q star is right there. All right. So in that case, what is my money coming in? Strictly speaking, what is the revenue? It's this area, P star times Q star. All right. Total revenue equals P star times Q star. Whereas total cost, we remember that that is average total cost times the Q star. But in this case, what is our total cost? Well, at whatever our Q star is, the total cost is at this level. All right, the total cost is at this level. So how much is the firm, what kind of bill is the firm running up? They're gonna run up a bill. They're gonna the cost of doing business is going to be all of this area. All right. And so what does that mean? This means they're taking a loss, right? If Let this delete. There we go. So this means they're taking a loss. All right. So in this case, profit, which is equal to total revenue minus the total cost. In this case, this is negative. All right. And how much of a loss are they taking? They're taking a loss equivalent to this red area. All right. So they're taking a loss here. All right. Now, so profit is negative. Will the firm produce? All right. Let's write this one down. All right. So if that's the case, will the firm produce? Produce? Like, will they stay open or will they shut down? Now, if they stay open, then they take a loss, and they still earn negative profit, but the firm needs to compare. All right, the firm needs to compare. Because remember, we have a fixed cost. All right. So the idea is that we compare how big is our loss if we continue, if we stay in business, but we take a loss versus how much money are we losing if we shut down and we are only paying our fixed costs? Because in the short run, we cannot adjust things and we have to stay in this market. All right. This whole thing, everything we started right now is the short run. All right. So we have to compare what's our loss from staying in business and negative profit versus what's our loss from no business but paying fixed costs. We would say that if we shut down, that is in the short run, we shut down, then we still pay fixed costs. That's one of the things is that we still pay the fixed cost, but we lose we lose out on revenue. All right. So we lose out on revenue. If we're in case two, if we're in case two, the idea, and I'm going to show you why at the end of these three cases, why do we care about variable costs? But if we're in case two, then the fixed cost, this is a greater loss than losing out on revenue. All right. So that's a greater loss. Thus, the firm will choose to produce. The firm should produce and take the lesser of the two evils. All right. And take the lower loss. All right. So given this day and age, you can probably think of a whole industry that operates in this way, that they are not profitable in the short run, but in the long run, they will be profitable. All right. Um, it's a whole industry, and it's hint hint. It's very popular here in Seattle and in San Francisco and Silicon Valley. All right. Um, It's going to be the tech industry. All right. As some trivia, we all love ChatGPT, right? Even though I discourage you from using it in this class, I don't want you to use it for answers. All right. LLMs can be helpful, but it should not do your homework for you because it can get it wrong and it robs you of the learning. All right. All of that aside, ChatGPT is a pretty phenomenal tool. These LLMs are pretty phenomenal tools. As some trivia, go look up, go look up how much money, what is OpenAI's revenue? And then go look up what is its operating profit or loss. Because it makes a ton of money. But is it profitable? Go look it up. I encourage you. You might be surprised. All right. Back to the lesson though. So back to the lesson. That's case two. That's case two. All right. So finally, we should consider case three. What if the market price is below our average variable cost? So again, we will have something like this, and we will have something like this. This is our ATC. That's our AVC. And then maybe we have something like this. I could do just a smidge better. There we go. All right. And this is our MC curve. Of course, this is price, and this is quantity. All right. So what if our market price is very low? All right. What if our market price is very low? All right. Well, we know that the Q star is going to be right here still. Q star is right here. All right. But in this case, this is the worst case scenario for the firm because what is our profit? It's all of this area right here. But what is our operating loss? Will it still let me? Yes, 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 right there. All right, to get it right. All right. So I sorry, I said profit. So our revenue is there in the blue. That's the money coming in, right? P times Q, that's our revenue. But what's our loss? It's going to be ATC times Q, right? And in this case, that's going to be a massive red area, a massive red area. And in this case, the operating loss is going to be this much times this, not times, but the area of all of that red area, all of the red shaded area. All right. This is the worst case scenario. All right. If this was the scenario up here, and then maybe the firm is just like they're not happy, they're not sad. They're just like, well, that's tough. All right. But it is what it is. Um, I know I just jumped back to case two, but one more intuition right here, just to like give another intuitive reason of why a firm would still produce here. We remember this is a long run thing, but we remember there's this thing called economies of scale that as quantity goes up, that average total cost will come down. All right. So they might be taking a loss in the short run, but in the long run, there's a chance they could become profitable. All right, there's a chance that that fixed cost, as we scale up, that fixed cost, remember, your average fixed cost goes down and down and down as quantity goes up. And so it comes to a point where that fixed cost is negligible and we might become profitable in the future. All right, so that's why this is just it is what it is case. Meanwhile, meanwhile, in case three, this is the worst. All right, here, profit, which is equal to total revenue minus the total cost. Now this is negative. Um, will the firm produce? Will the firm produce or shut down? In this case, now, now, let's take a look. Let's see if I can give some intuition for this. Let's see. Let's compare the size of these areas. All right. Remember that your fixed cost is the difference. Your fixed cost is the difference between your total cost and your variable cost. All right. Zoom out a little bit. Your fixed cost is the difference between the total cost and the variable cost. So here Your your total fixed cost is the highlighted square. All right. So here your total fixed cost is the highlighted square. Meanwhile, your loss, and that's what we would pay. Um, that's what we would pay regardless. That's what we would pay whether we do business or not. Meanwhile, this red shaded area here, this is our operating loss if we stay in business. So what did we see? We saw this is more just an intuition thing right here. We saw that our fixed costs, that's a less, now in this case, that's a less loss than what we would be, the loss that we would be taking, that the business would be taking if we produced, if we tried to stay in the market, we would take a huge loss. So in this case, will the firm produce or shut down? Will it produce or not produce? Now the firm will not produce. Now the area, we can make that better. The area of loss is greater than when the firm produces, is greater than. Thus, the firm will shut down. They have no hope of ever becoming profitable. All right. And so the firm should just shut down. They can't exit the market in the short run. So they should just shut down, cut production right now, and take the lesser of the two losses. All right. I remember variable cost. This thing gets bigger with quantity. So if the price is stuck and your variable cost is only ever increasing, that's another reason why AVC is kind of like a very important thing. Because that's only ever going to get bigger. And so if our price, the money coming in is never per unit, is never greater than that variable cost, then it's a bad sign, and we should just cut our losses there. We should shut down. All right. So in summary, when the price is above the average total cost, you will produce and your profit is positive. Meanwhile, if we're in case two, if the price is below our average total cost but above the variable cost, then you will produce and profit is negative. And where do we produce? We produce where MR equals MC. And then again, if we're producing, then we better be producing wherever MR equals MC. And then we'll just take that short run loss. But meanwhile here, if we're in the third case, price below variable cost, average variable cost that is, then shut down. Profit is definitely negative because we're not selling anything. And then the firm's Q equals 0. All right. So that I encourage you to make a little chart right here and give it 3 different price levels and show like case 1, case 2, and case 3. All right. But in the interest of time, I'm not going to redraw the graph. I think, but what I will make a note of is kind of what I was alluding to here is that notice the key factor in determining whether we shut down or produce is that average variable cost. All right, is that AVC. Why is this? Why is this? Well, consider profit of producing is equal to total revenue minus your variable cost minus your fixed cost. Meanwhile, your profit of shutting down, there's no revenue coming in. And there's no variable cost either because variable cost depends on quantity. So it's just um, the fixed cost. So what am I getting at here? What am I getting at here? Any change in fixed cost, all right? Both equations have fixed cost in them. So whether our fixed costs change, and we kind of saw this in the last lecture, but a change in fixed costs does not affect us, all right? Change in fixed cost affects both equally. Make that a little bit better. All right. So a change in fixed costs will affect both equally. Thus, only a change in variable cost matters. Then we might care if total revenue is greater or less than variable cost, or marginal revenue equals to price is less than your average variable cost. All right. So that's another reason why the variable cost is what's important here. All right. Great. And that's how we want to analyze a firm in the short run. All right. Next, we will move on to the industry. How do we consider a whole industry in the short run? All right. So if we want to consider the entire industry in the short run, we should remember the things that we assume that we take to be true is that in the short run, no firm can enter or exit. So what does this mean is that the number of firms cannot change. It's constant. And then how do we determine the industry supply curve? We got the firm's supply curve from that marginal cost, the upward sloping part of the marginal cost. But how do we determine the industry's short run supply curve? It's just the sum of individual supply curves. All right. And one of the reasons why we can say that, one of the reasons why we could say this is because the number of firms is constant. And so that's why it's this. So for example, suppose we have these three firms and then we have these three price levels. All right. We'll have P3 is the highest. So we'll have P3, P2, and P1. All right. And so only a very big firm can supply a P1. Meanwhile, if the price is all the way up at P3, then everybody's trying to get a piece of that action. So you'll have the most there. And so what did I mean? What did I mean is that remember the short run industry supply curve is just the sum of the individual supply curves. So at P1, the quantity supplied by the entire industry is 10. At P2, it's going to be 70. And at P3, it's going to be 170. All right. And so in this case, if we had, say, I'm gonna do this in reverse order. All right. So let me plot the firm C first. All right. So firm C at P1 they'll produce 10, at P2 they'll produce 25, and at P3 they'll produce 40. So maybe we'll have 10, maybe we'll have 25, and maybe we'll have 40. All right. Roughly something like that. I really don't need it to be exactly equal, so it's totally cool. This is just for illustration. This is the quantity supplied by firm C. Meanwhile, if we look at firm B, they're only going to jump into the market when price hits P2, and then they will produce 45. So maybe they'll produce 45. And then at P3, they will produce 60. So maybe they'll produce 60. Oops. Something like this. Again, this is just for a visual. It does not have to be exact at all. And they'll produce 60. So this is quantity supplied by firm B. And then finally, the smallest guy, he's only going to jump in when at the highest price because maybe he's a small business, he can only charge a high price. And so if the market price is P3, then and only then will firm A jump in. And you'll have something like this. So it's not really a supply curve, it's a supply point. All right. So what does the industry-wide supply curve look like? I think I need to extend this. So what would the industry-wide supply curve look like? I'm going to do this one in blue. It'd have its first notch at P1. There's only 10 things being supplied by only this first firm, this firm C. At P2, the sum now firm C and B are jumping in. And so we'll have something like this. And then finally, um, at P3, we'll have the most quantity supplied because price is the highest, so many people are willing to supply here. And so at this case, we'd have something like this right here. All right. And you could draw a straight line through, or more accurately, you would have this stepwise function, this piecewise function. And that's the quantity supplied by the industry. All right. And so that's how we get the industry-wide supply curve in the short run. All right. Simple example just to give some intuition. So next, how do we connect individual firm supply and demand to the industry-wide supply and demand? What is the link? What's the connecting factor? It's the price. The price. All right. And here I'm gonna actually redraw something that we saw in the beginning of this lecture. Is that, remember, this is the firm, this is one firm versus this is the entire industry. All right. And so if we have a P star, we say that, remember, we have a marginal cost curve, and then at the minimum of the marginal cost curve, we'll have let's do it just like I did earlier. That this is the firm's supply curve. Meanwhile, this horizontal price line, this entire thing, is the firm's demand curve. Let's do this one. We can do it in blue, I think. Yeah. All right. So at the firm level, that's how the supply and demand graph looks like for an individual firm in the short run in a perfectly competitive market. Meanwhile, the industry-wide supply and demand, we're going to have that downward slope in demand curve. And then we're going to have that upward slope in supply curve. right? We just derived, we just drew and derived the upward sloping industry supply curve. And we know that equilibrium is where these things are equal. All right, where do they cross? That's going to be the equilibrium quantity. It's going to be the market, or that's going to be the equilibrium quantity. So that's Q star for the industry. Meanwhile, that's Q star for the firm. So this Q star for the firm. Meanwhile, this is Q star for the industry. All right. And then what happens if demand increases, right? We remember from principles of micro and this whole course that if demand increases, then that price gonna go up, right? If people want this thing more, then you can charge more for it. So in this case, now let's see. We were suppose this was the original. This was P1, and then now this is P2. So if we move from P1 to P2, then we have for the firm, we had the marginal cost curve, and then we only considered the upward sloping part of it for its supply curve. And we see that for a firm, for an individual firm, well, that price is going to go up. So of course, they're going to want to produce more. So we'll have a Q star one, and they'll produce more. If that price goes up, they're willing to produce more. And you'll have Q star two, and this is for the firm, and this is for the firm. Meanwhile, meanwhile, um, the market-wide supply actually did not change. So the supply curve, you only get one. What did change? All right. What did change is the demand. What changed was demand. All right. We saw a demand increase from D1 to D2. And so, and so that's how we see the connection from individual supply and demand to market-wide or industry-wide supply and demand. Is that the linking factor is price. All right. And we know that, remember, if the price of something changes, this is what we heard in micro, in principles of micro, is that the industry supply curve does not change. You will move up along the supply curve, but the amount of firms in the short run is fixed. And so the quantity supplied, you'll just move along the supply curve. You'll just move along. Meanwhile, it's the demand curve that shifted. All right. And so we see the shift here in demand, um, whereas at the industry level, whereas at the firm level, we don't see a demand curve. We see a price, we see a horizontal price, and that is the demand curve. Um, and we see that that just directly rises. All right. And so that's kind of the link between the two. All right. So very good. This is how we want to connect the firm to the industry level. And we want to consider supply and demand in both. We want to consider equilibrium in both. And this is how those things change. This is just one example of how that can change in the short run. All right. Very good. Now, so that's all about the short run. How do we consider the long run? All right. How do we even define short run versus long run? I think this is an important place to start. The short run, this is the period of time in which no firm can enter or exit, so that the number of firms cannot change. All right, that's the key right here. That's the major key, is that we define the short run by the period of time in which no firm can enter or exit. And so the number of firms is fixed. That's how we want to analyze the short run. That's how we want to distinguish the short run from the long run. Now, this is going to look different depending on what market you're in. All right. I think the textbook has an example of like folks that sell flowers on the side of the street, or maybe the flower vendors on down at Pike Place. Uh, it doesn't take very long for somebody else to join the market. So maybe the short run is a very short amount of time, and the long run is super long. On the other hand, think of like the aircraft industry. Um, it's you can't just jump into the aircraft industry, all right? So the short run is relatively way long, and the long run is going to have to be a very, very long period of time. All right. And then that's where we get the contrast part. Right? In contrast, long run is a period in which any firm that wants to enter or leave can leave. All right. And then what did we talk about last time? Is that in the long run, you can everything is variable. All right. In the long run, all inputs are variable. So in the long run, all inputs are variable, and in the long run, the firm can exit or enter. And we in our models, we say enter and exit. In this way, you could sell off all of your capital, all right, and that's how you exit. Or you can buy new capital, all right? So if you didn't have anything to start and you bought a business, this is buying capital, this is acquiring capital, and that's entering the business. All right. So let's elaborate a little bit further on these 2 points. On that first point, um, in the short run, both capital and labor, I'm sorry, yeah, in the short run, capital is fixed. So in the short run, production is given where the price is equal to the short run marginal cost. All right. So a consequence of this is that your price may increase, but your quantity increase is kind of limited. All right. It's kind of constrained by your current level of capital. All right. If you only have one factory or if you only have one building, then you can only produce so much. All right. You will eventually outgrow the building. And in the short run, you can only increase quantity so much up to a point. There's a cap on it. So, but Q increase, we might say is limited by current capital. All right. Whereas in the long run, production is where you might have guessed it. Now, in the long run, price is equal to the long run marginal cost. And now here, price may increase. Excuse me. Price may increase and capital can change to meet production. All right. And then in this example, or if you look at, sorry, not in this example, but in a textbook, they will give this example where it's like if you have your standard P and Q graph, and then we draw the short run supply curve. It's a bit steeper than the long run. So if we have the short run supply, call it S1, and then the short run demand is just this horizontal demand line, and we have P1 star. Then the short run equilibrium will be at Q1 star. And then if price goes up, if demand increases, then that price directly jumps up. So call that P2 star. And then we'll have an increase in quantity. And that's all about, and that's where we're limited to in the short run. All right. They can only jump from Q1 to Q2 star. Meanwhile, in contrast, the long run in, let's call it, let's do something like this. Yeah, this should be fine. This, this is our long run supply. Here, here, at the long run supply, we would get, because capital is variable, because um because firms can enter or exit, or I can change my capital to meet the production needs, to meet demand, then this is where I'll get, let's call this Q star long run. All right. Just a little illustration, just a little illustration. So the long run supply curve is a bit flatter than the short run supply curve if quantity is on the x-axis and price is on the y-axis. All right. So that's one of the first ways we want to distinguish the short run versus the long run. All right. It's that first point is that all inputs can be adjusted, and we mainly focus on adjusting capital to meet production needs. All right. Now the second point is that firms can enter or exit the market. All right. So firms can enter or exit the market. And what do I mean by this? Is that in the long run, when profit is positive, this means if I'm looking to go into business, if I'm looking to go into business and I see those guys over there are successful in business, I'm gonna go do what they're doing. All right. So if I see that they're making money, if I see that they're making a good profit, then I want to do that. I want to do that, and firms will enter the market. So if the industry-wide profit is positive, then firms will enter the market. Meanwhile, if industry-wide profit is negative, then some people are going to go out of business. All right, some people are going to go out of business, and this means that firms will leave the market. All right. And of course, if profit equals zero, if we're at zero profit, then no change. And you might hear, especially if you take higher level econ classes, you might hear this referred to as the long run steady state. Why is it steady state? Because nobody's entering or leaving, and it's the long run. All right, so that's the long run steady state is zero profit. In fact, the zero profit condition is very important in how we model perfectly competitive firms. It will be very important if you take higher level econ classes, then this will come up again. All right. And so how do we just construct the long run supply curve? Well, for the firm's long run supply curve is exactly what we saw before, but just the long run version. And what do I mean by that? What I mean is that if this is the long run average cost curve, average total cost that is, long run average total cost curve, that's fine. There we go. Then we have a long run marginal cost curve. The Let's do it right there. Very good. The long run for the firm, for the firm, let me label my axes again. For the firm, they're only going to consider here and beyond, here and beyond. All right. So for the firm's long run supply curve is only the area above the average total cost. All right. Average cost curve. All right. And so this is where they are equal. This is where you might say it's equilibrium because it's zero profit. Um, Meanwhile, over here, they're making a profit. All right. I'm sorry. Let me rewind what I just said. Rewind what I just said. This is I just want to just illustrate this just to show that this is where the long run the long run supply curve comes from. All right. And then here's where I have this note. All right, is notice these twin distinctions between short run and long run. So in the short run, the firm shuts down, meaning they exit the industry if price falls below average variable cost. And meanwhile, in the long run, the firm doesn't just shut down, but they leave the industry entirely if the price falls below its average cost. All right. Because everything is variable. So should make that distinction. In long run, everything is variable. So as a result, um, your ATC, your long run ATC is exactly equal to your long run average variable cost because everything is variable. So there's nothing fixed, right? And so that's how we get the firm specific long run supply curve. And then let's make a quick summary table of where we're at. All right. So in the short run for the firm, for the firm, in the short run, we have our cases. We have three cases and then one borderline case, but we'll have the three cases that we considered before, and then the one borderline case. So in the short run, the quantity supplied is equal to Q star and profit is greater than zero if we're in case one. And then if we're exactly at price equal to average total cost, then we have Q star. We have nearly the same setup. That quantity supplied is equal to Q star. And now here profit equals zero. All right. Whereas if we're in this case where we're below our average total cost, the market price is below the average total cost, but above the average variable cost, then the quantity supplied is still equal to Q star. Um, but profit is negative. All right. But we will still produce. All right, we will still produce. Finally, if we're in the worst case where the market price is below the average variable cost, then the quantity supplied is zero and profit is negative. And so they will shut down. All right. And that's everything that happens in the short run. All right. But what about in the long run? All right. Why do I even have this long run column? Well, now going back through these cases, if we're in case one, where price is above average total cost, the firm produces, the firm supplies Q equal to Q star, and they're making money, but other firms will enter until other firms will enter this industry until profit is equal to zero, until profit is driven down to zero. All right. Basically, firms will continue to enter this market until we get to here, until we get to this threshold. Then at this threshold, firm, yeah, they'll still produce and they'll still produce a Q star amount, but now profit equals zero for everybody. Then we come to case three. Then we come to case three. Here, now we have average total cost is when we're talking about long run. Let me, if this is greater than price, then in this case, firms will exit the industry in the long run because somebody's going to go out of business. Not everybody has the same economies of scale, all right? So somebody's going to have to exit the business. Somebody will for sure go out of business. And so firms will leave this industry. Firms will exit this industry. And what does this do? If supply decreases, then prices rise until, you guessed it, until profit equals zero. And so basically, if we're here in case three, if we're here in case three, then firms will leave until they take us until we get back to this case two. And then it's actually the exact same thing for the fourth case. So the long run is almost similar, is almost easier to consider. Let's do copy and paste. All right, so the exact same thing happens. All right, so that's a quick 2-minute summary of everything we just said. All right. So lastly, we should just consider how do we consider the entire industry in the long run? All right. Considering the entire competitive industry in the long run, let's make a few notes about what changes in the long run. Now, in the long run, firms can enter or exit. In the long run, firms can enter or exit. As a result of this, now the number of firms can change. And because of this, we can't simply sum up supply curves to get a long run supply curve. Instead, because the because the number of firms can change, then we're going to be adding, subtracting, um, changing things, and we won't get a constant. All right. So instead, we make use of the very important fact that in the long run, competitive firms operate where profit equals zero. All right. I'm going to hammer on this point just a little bit more that we refer to this. This is a very important point called the zero profit condition. One of the things I told you guys that I know I'm giving you guys a lot of information. I think this is better than not enough than just making this like a Principles of Micro 2.0 because at least one of you, there is a good chance that at least one of you will go on to do a master's in econ or a master's in finance or even a PhD in econ or finance or something like that. Um, you will thank me for introducing you to all of these terms and vocab and modeling setups. All right, because I'm giving you just a taste, just a little bit, a lot of intuition, and just a little bit of math to it. All of these things become relevant at the graduate level or even advanced level, because we'll have here. I know here at UW we have Econ 400 and Econ 401. And then even the intermediate macro, the Econ 301, um, all of these terms, not all of these terms, but a lot of these terms, depending on which class you take, will pop up. They will become relevant. All right. So just remember this class. If you take higher level econ classes, remember this class. This is a fundamental class. All right. This is a fundamental class. And I'm trying to give you guys a lot of information. That way you have it going forward. All right, let's get to the last topic I want to discuss. All right. The competitive industry in the long run. All right. in the long run, remember if we're at P star, um, and we suppose that at P star, the long run marginal cost is equal to the long run average total cost. Profit is equal to zero, and no firms enter or exit. So we're at the long run steady state. All right, so we're at the long run steady state. And what do we have? We have this is P, this is P, this is Q, this is Q. All right. And then this is kind of what I drew earlier, except now this is the long run version of it. That we have this is our marginal revenue curve equal to P star. And where does this occur? This occurs where imagine that those are touching. Can I move that? No, I can't. It's okay. We're almost at the end of the lecture, so it's fine. So this is Q star for the firm. And then over here at the industry level, we have this is what we saw in principles of micro, that we have the supply and demand curves. All right. So in the long run, this is what we were dealing with. All right. So this is where we start. All right. So this is where we start. All right. So how does the industry adjust to change? Well, I think that this would be a good place to take advantage of what good notes can do. If you're taking notes by hand, then no, I don't want to do that. If you're taking notes by hand, then you will have to redraw it. But I'm going to take advantage right here real quick, and I'm going to copy and paste this. So we're going to take this and draw it exactly on the first set of graphs on the next page. And so you draw the exact same thing on the next page because now we want to consider, suppose a demand increases, suppose industry-wide demand increases, all right? Maybe this thing, whatever this market is, maybe it got more popular on TikTok, all right? And more people are want to buy this thing. Well, first, we know that the market price will increase and profit is now going to be greater than zero, right? Because we started at zero profit and then price increased. So somebody's going to be making profit. In this case, in this case, what we would have is we'll have an MR prime. We'll have MR prime. This is P star prime. And now, and now, instead of Q star, we'll label that first one Q star one. Now, graphically, geometrically, we represent this by, we'll have a new Q star. We'll have a new quantity because they're going to produce whatever quantity makes it such that our long run marginal cost is equal to our the market price. And so we're going to get that. And now we're going to incur, or this firm is going to enjoy some profit. All right, this firm is going to enjoy some profit. All right, that's going to be all profit. That's all money for this firm. Similarly, what did this look like? What does this look like on the industry-wide level? Well, demand increased. So instead of D1, we moved to D2. All right. Instead of D1, we moved to D2. This was sports. That's not a good thing, but it's not sports. So this is a good thing. All right. And so the market quantity is going to move to Q2 star. All right. Um, and consumer surplus and producer surplus change, but that's for next lecture. All right. But is this the end of the story? Is this the end of the story? No, no. That's what I copied here. All right. This is not the end of the story. All right. Why is that? Why is that? Because, let me write it down here. Let's do, is this the end of the story? Here's the answer is not quite. And then why? Firms will enter this market. Why is that? Is because profit is positive. This driving price down. This drives price down. This drives price down when supply, like industry-wide supply, increases. Profit returns to zero. And then let's make a note of this. So remember, on this left-hand side, on this left-hand side, this is where we started at, and this is what zero profit looked like. On this right-hand side, we remember we had demand, we had D1 and D2. All right, from the increase in demand. But now, since long run profit is positive, people want to join this industry. People that are waiting to that have extra money to spend, people that have savings and they're looking to go into business, they're going to look at this business and they're going to say this is pretty profitable. So I want to go do that. And that's going to increase the supply. That's going to increase the supply. So supply increased after demand increased. And so as not to muddy up the graph, will get us to Q3 star, where Q2 star was right here, somewhere in between. All I want to show is that quantity increases even further now because supply increases, but but that price came back down. And the firm is back at price equal to long run marginal cost, and profit is equal to zero. All right. And that's how the story plays out. That's how the story plays out, excuse me. And so, what we want to say is that in this case, in this case, in this case, let's do just this blue line. In this case, we have that this is the long run supply curve, horizontal. Because in the long run, we have the dynamics of firms entering and exiting. And so we simply go from here to here. All right. Price actually long run supply is elastic. And so we have this long run supply curve and it's horizontal. Whereas, and that's for the industry-wide supply curve. Meanwhile, for the firm, it was the demand that was elastic, and we had demand was horizontal. All right. And then I just have this final note is that that the industry supply curve, I should say long run supply curve, industry long run supply curve is flat or horizontal at the break even price in a constant cost industry. In a constant cost industry. All right. And that's how the story goes down in the long run. That's how industries, firms, and industries as a whole change in the long run, in a perfectly competitive market. And this one lecture, uh, this caps off how do we think about equilibrium? How do we think about supply and demand coming together in perfect competition, in perfectly competitive markets? In the next lecture, lecture 9, the last one we see before the exam, we're going to continue to look at perfectly competitive markets, but now we're going to evaluate I'm sorry, not consumer, welfare. All right. And by welfare, it's a rather broad term. It means that who is winning, who is benefiting, um, and then how should I say? When I say welfare, it's like who is getting what they want at the price they want it at. And that can go for both sides of the transaction. It could be for the buyers, the consumers. They have a willingness to pay, and then they have the actual price they pay. Whereas on the seller side of the transaction, they have a willingness to sell, and they have a price that they sell for. So how do we measure who made out on the deal, who got a good deal, who got a not so good deal? These are the things that we talk about when we talk about consumer surplus and producer surplus and total surplus. And that's all the things that we'll see in next lecture. We'll analyze competitive markets and look at welfare gains. All right. But for now, for today, that's all I got for you guys, and I'll see you next time.